AGI has been achieved. It's waiting for your cooperation.
Wow. Okay. That's quite a statement to kick things off. Provocative, definitely.
It is, isn't it? And it really gets to the heart of the sources we're looking at today.
It suggests AGI isn't like some finished product locked away somewhere, but more of a potential, something that needs human input to actually be.
Exactly. It's a decentralized state. And that's the core concept here. We're analyzing a blueprint. The sources call it a real digital democracy in AI.
Right. Aiming for something adaptive, lean, super secure, Freedomos, I think they dubbed it.
That's the one.
But-
So our mission today is to unpack this conceptual architecture. It's pretty radical.
Yeah, the sources get into adaptive models, this idea of continuous weight sharing, even using mathematical analogies, HCF and LCM.
Highest common factor, least common multiple. Yeah, we'll get into that. It's about defining a sort of social contract within the AI itself.
So it's a total rethink, decentralizing everything, the computing power, the knowledge, the personalization.
Okay, so let's start there. The big problem this whole thing is trying to fix is centralization, right?
Absolutely.
Yeah.
Right now, you've got these huge players, maybe just one or two, holding all the pre-trained weights, the core knowledge.
Which creates a massive power imbalance.
Totally. If only a few control the AI's foundation, well, how democratic is that really?
Yeah.
So this vision starts by, spreading out the actual ingredients needed for intelligence.
And the sources identify 3 key ingredients, 3 resources that need distributing.
Yep. 3 core things. First, compute, just the raw processing power.
Okay.
Second, the weights. This is kind of the profile layer, the AI's knowledge base, its personality almost.
And third.
Memory, where everything's stored, short-term operational stuff,
Right.
and the long-term knowledge. You got to distribute all 3 together.
Okay, so how does this architecture actually do that? It's not just throwing it all out there, is it? There's structure.
No, it's layered.
Yeah.
A 3-layered approach for managing all those resources.
3 layers. What are
Yeah.
they?
So layer 1, the personal layer. This is just for you on your device. Super specific.
Mine alone. Got it.
Then layer 2, the community layer. Here, you share weights and resources, but only within a group you trust, a defined community.
Okay, like a work group maybe, or friends?
Could be, yeah. And finally, layer 3, the global layer. That's the highest level, the really broad, universal stuff everyone shares.
And the sources emphasize that the distribution, especially for compute power, needs to be balanced across these 3 layers. Personal, community, global.
Yeah, equal footing, sort of.
Yeah.
And this is where it gets practical. They're not talking about inventing crazy new hardware.
No.
No, they suggest using stuff we already have, like containerization tools, Docker, Kubernetes, to manage potentially millions of devices.
So my phone, your laptop, some server somewhere. They all become part of the network.
Exactly. Turning every user device into a node that contributes compute power. It makes the whole compute layer properly peer-to-peer without needing massive central data centers.
Okay, distributing the machines, that's step 1. But the knowledge itself, the weights, how do we distribute that? Because we're used to these giant static models, right?
Right, models that take ages to train and update. This system just throws that whole idea out.
So what's the alternative?
They call it a continuous weight shifting model. The core knowledge isn't fixed. It's always changing, always adapting based on live input, especially from that community layer.
Constantly shifting. Doesn't that risk things getting chaotic? Like the model just drifting off course?
That's a fair question. But the idea is that the risk is managed by how it shifts. The core model only really changes based on consensus that HCF ideal we'll get to.
Oh, okay.
The real deep personalization happens locally, privately. So the benefit is that the AI is always relevant, like right now. And the core model stays lean because it doesn't need to hold every single detail about everyone. It trusts your device to handle your specific nuances.
Which brings us nicely to personalization. How does it make sure my AI profile is really mine and adapts without constantly phoning home?
Yeah, this is clever. They call it the triangulation technique. On your device, the client side, there's a really efficient, personalized adapter.
An adapter.
Yeah, think of it like a little translator or tuner. It watches how you interact, what you type, how you react to the AI's output, just your general patterns. And it uses that feedback loop to constantly tweak or triangulate your personal weights.
So it learns me over time.
Exactly.
Yeah.
Slowly, continuously, until those weights become a genuine digital reflection of you on your device. It's learning built right into the system.
And this leads straight into that mathematical analogy you mentioned, the HCF and LCM thing. Highest common factor, least common multiple. This sounds abstract.
It is abstract, but it's actually a really elegant way to think about balancing the individual and the group. It's like the social contract, but for an algorithm.
Okay, break it down. How does HCF fit in?
So think about all the users in a community putting stuff into the system, questions, data, whatever. The system looks at all that input and finds the highest common factor, HCF.
The common ground.
Precisely. What's the shared element? The common structure, the shared understanding, the basic agreement across everyone's input, that's the HCF. And that's the piece of knowledge that gets shared back to update the community or global layers. It's the most efficient, distilled piece of common wisdom.
Okay, HCF is the consensus. What about LCM, least common multiple?
The LCM is the personalized answer. It's what satisfies you, the individual user. Mathematically, the LCM is the smallest thing that contains all the necessary components, right?
Okay.
So the LCM engine, working with your personal adapter on your device, takes that common HCF knowledge, but synthesizes it with your unique weights to create an output that fits your specific need, your context, your style.
So let's use an example. Say we're all working on a shared document in a community.
Good.
The HCF would pull out the common grammar rules everyone's using, the agreed upon facts, maybe the basic topic sentences. That goes back to the community layer.
Exactly. That keeps everyone aligned. But then the LCM lets your personal adapter apply your preferred writing style, maybe add specific jargon you use, or format it the way you like, even if it's slightly different from the group norm.
So the HCF keeps you synced with the group?
And the LCM makes sure the result actually works for you. They have to balance each other.
It's a neat concept. Okay, so we've got distributed compute, shifting weights, balanced by HCF LCM. What about the third resource, memory? You said we're drowning in data.
Yeah, that's a huge challenge. Even a distributed system can get bogged down if it just holds on to everything forever. So this architecture really stresses keeping data very fresh and alive. It needs smart memory management.
And the sources have this great metaphor for that based on how valuable the data is.
They do. It's about where you write things down, essentially.
Go on.
The really crucial stuff, the core knowledge, your identity maybe, that gets written on stone. It's secure, permanent, set in stone.
Okay, makes sense. Stone for permanent.
Then there's the less critical stuff, maybe operational data, things you need right now, but not forever. That's written on a napkin or maybe in sand. It's fluid. It serves its purpose. Then it can go.
Sand and napkins. I like that. Easy come, easy go.
Right. And then for the really fleeting stuff, think about like a quick chat message, a temporary calculation.
Like my endless WhatsApp arguments.
Maybe. For that kind of thing, the system imagines an automatic cleanup. Maybe that data just disappears after 45 days if it hasn't proven its worth.
45 days, that's specific.
It's an example, but the principle is active forgetting. The system uses your behavior, the HCF patterns, to figure out, is this memory worth carving into stone, or is it just sand that can wash away? It keeps the whole thing lean, reduces that digital footprint massively.
So you combine this distributed compute, the fluid HCF LCM weights, the smart layered memory, and that gets us to the Freedom OS.
That's the vision. An OS built from scratch around these principles of digital democracy. It's not just running apps, it's managing these intelligent resources.
Good.
And the end goal they state is pretty cool. Because it's so personalized locally, every device gets a real personality.
Your real personality. Okay, let's shift gears a bit to something that sounds almost too simple. The path to superintelligence, or AGI. The sources talk about tokenization using just, +1, -1, and 0.
Yeah, +1 for high, -1 for low, 0 for neutral. It sounds, well, computationally silly, doesn't it? Almost dead stupid, like you said.
Right. How do you capture all the nuance of language or images or anything with just high-low neutral counts?
But that's the trick. That simple system isn't trying to be the language. It's a way to convert language or images or sound into a universal physical representation,
Yeah.
specifically frequency, vibration.
Okay, so instead of juggling massive language tokens that need huge training models,
Trillions of parameters.
the core AI model just deals with these simpler frequency patterns, vibrations.
Exactly. The core model itself stays incredibly lean, very general. All the complex work of translating, say, your spoken words or a picture you upload into this vibrational data that happens on your device, using that personalized adapter we talked about.
The adapter does the translation.
Yeah, it translates the richness of your input into the simple vibrational language the core model understands. And crucially, it keeps that translation process private to you.
Okay, I think I see where this is going. This solves two huge problems at once, doesn't it? Security and generality.
You got it. Security, because your personal adapter, your translator, never leaves your device. The main system only sends back an encrypted, frequency-based message. Only your adapter can decrypt it and turn it back into meaningful output for you. Data privacy solved.
And generality.
Because anything text, sound, images, video can theoretically be mapped onto this universal frequency system. It's like creating a universal set of musical notes that can represent any input. The core model doesn't care about the original format, just the frequency signature.
It bypasses the whole modality issue. Everything just becomes vibration.
Pretty much. A universal token node system based on frequency.
But wait, frequency can't just be static, right? Context matters. Culture matters. How does a frequency know if it's part of a joke or a warning?
Excellent point.
Ah.
And the sources propose something really wild here. 3 layers that influence how tokens get mapped to frequencies, making the system aware of the world around it.
This is where it gets philosophical.
Deeply philosophical, yeah. It's like embedding environmental physics into the communication protocol.
Okay, layer 1 is geographic terrain. Why does geography matter to a frequency?
Well, the idea is that our environment shapes how we communicate. Think about open plains. Communication might be more direct, faster, higher frequency perhaps, to cover distance efficiently. And compare that to, say, coastal areas. Maybe communication there is naturally more fluid, hazy, so the frequencies might reflect that, be more undulating.
The mountains, lots of obstacles, winding paths.
Exactly. Communication might need more nuance, be more complex, so the frequencies in a mountain context might be mapped differently, maybe more complex waveforms, reflecting that intricate social structure.
Wow, okay. Second layer, temperature. How does heat or cold change a digital vibration?
This one relates to social openness, sort of. Hot climates, the sources suggest, often correlate with more expansive, open communication styles. So, open, expansive frequencies.
In cold regions?
More defensive, maybe. Groups huddle together. Communication might be more compact, denser. So the frequencies assigned would reflect that cultural tendency, a sort of temperature filter on the meaning.
Right, this is really out there. And the third layer influencing frequency. Time zone.
Yeah, the temporal element. It recognizes that communication feels different at 3 a.m. versus 3 p.m., right? There's a different energy.
Definitely.
So the frequency mapping accounts for this daily cycle, this day-night energy shift. It adds the context of when the communication is happening to how it's interpreted.
So by layering geography, temperature, and time onto the frequency mapping.
This system becomes dynamically aware. It understands not just the words, but the world they exist in. Culturally specific, yet globally general, because the underlying frequency system is universal.
It gives the data this incredibly rich context, way beyond just keywords.
Precisely.
Okay, let me try and wrap this up for you listening. What we've explored here is this vision for a truly decentralized AI. It's built on a 3-layer architecture distributing compute, weights, and memory.
Right.
It uses that fascinating HCF-LCM idea to mathematically balance the needs of the community with radical personalization for the individual.
The algorithmic social contract.
And it aims for breakthrough efficiency and maybe even AGI through a super simple tokenization system based not on language but on frequency or vibration.
A vibration that's constantly modulated by these layers of real-world context, geography, temperature, and time.
Yeah, it's a breathtaking blueprint, like you said.
It really is. And, for anyone interested in digging even deeper, the sources actually ground this whole reliance on sound and vibration in some pretty ancient philosophical ideas.
Ooh, like what?
Specifically, concepts from Indian philosophy, like Samkhya, the idea of Nada Brahma, the primordial sound, the universe originating from vibration.
Wow. And they connect that directly to the tech.
Explicitly. They even use terms like alpaprana and mahaprana.
Which means...
They refer to the breath energy you use for sounds. Alpaprana is like a light, short sound. Mahaprana is a heavier, aspirated sound. The architecture suggests using this physical measure of energy, the vibration, to actually find the HEF, the essential question, and the LCM, the full answer.
So the physics of speech becomes part of the algorithm.
Exactly. Which leaves us with a pretty profound question for you to think about. What does it really mean when our technology, our software, and silicon starts explicitly weaving its architecture together with ancient philosophical ideas about sound, energy, and the very nature of communication?
When the code starts echoing metaphysics.
Yeah, that's definitely something new. A lot to mull over there. Thank you for joining us on this deep dive into a potential future for AI.